Welcome students to my new channel which is called Law of Physics. In this channel I discuss about problems which students come across while solving JEE and NEET physics. So in today's session we'll see some problems on electrical circuits. So let us see the first problem. Now this is the circuit shown. For this type of circuits you have to draw a simplified circuit. Actually this circuit is a example of Wheatstone bridge. So what we do here is we'll identify the points. See, because there is a wire here and there is a resistor here, so this point potential, let us say it is C, and this point potential, let us say it is D. So we have to read out the circuit. The circuit will look like this. So see, from A to C 6 ohms is there, then this point I will call it as E. So from A to E 8 is there, so this is 8. Then C to D 3 is there, I'll call this point as D. C to D 3 ohms is there, and from E to D 4 ohms is there, and finally from D to B 7 ohms is there. So like this you have to make a simplified circuit, and you can see here from C to E there is 10 ohms. So this is a balanced Wheatstone bridge because 6 into 4 24 and 8 into 3 24. Okay, you have to just cross multiply like this, then we'll come to know whether it is a balanced Wheatstone bridge or not. In this situation no current will go through this branch. This and this will be in series, which is 6 plus 3 9 ohms. This and this will be series, which will be 8 plus 4 12 ohms. Now when you add, these two are in series and these two are in series, so these two will be in parallel. So how do we find the resistance of parallel? Means R1 R2 by R1 plus R2. So 9 into 12 by 12 plus 9, which is 9 into 12 by 21. So 3 3s are 3 7s are, so it is 36 by 7. Okay, so this whole is now 36 by 7. For that you need to add another 7 because that is in series. So 36 by 7 plus 7, so it is 36 plus 49 by 7, which is 85 by 7 ohms. So from A to B the effective resistance is 85 by 7. Let us see the second problem. In this type of problem can be solved by Kirchoff rules also. Kirchoff rules. Here we are trying to find out the branch current values. We are trying to find I in different branches. Okay, but I am going to use a method called nodal analysis. Okay, now when to use this method means whenever you find these type of open wires, you can use nodal analysis. In nodal analysis what we do is we just try to find out the unknown potentials. The known potentials we'll write. So if this potential difference is 10, that means this point it will be 10 and 0, and this point it will be 10. The potential difference between this point and this point is 10. So you can see there is no resistor here, so this point potential is also 0, this also 0, and this also 0, and this point will be 20. So we can say that this point and this point are unknowns. I will call this as X and Y. We'll try to find out this unknown potentials, and once we know the unknown potentials we can find out the branch currents. So in this method what we do is, this point I will call it as P and this one as Q. So at point P, this if we apply KCL, the sigma I value will be equal to 0. In this method what we do is, when we apply this formula to the particular node, that node potential will consider to be higher. Okay, so if I want the current in this branch, let us say, so we can apply V is equal to IR formula, right? So V is the potential difference, which is 10 minus X minus 10. So X minus 10 divided by R. So that is the branch current here, plus between this point and this point it is X minus Y divided by 2, and plus between this point and this point it is X minus 0 by 2. is equal to 0 because sigma is equal to 0. Multiplying both sides with 4, we get x minus 10 plus 2x minus 2y plus 2x is equal to 0. So this is 3x, 5x. So 5x minus 2y is equal to 10. This is my equation 1. Similar concept we will use at the second node also. This time I will assume this potential is higher. So I will write the equation y minus x divided by 2 plus y minus 0, which is y, divided by 2 plus y minus 20. Y minus 20 divided by 4 is equal to 0. So multiply both sides with 4, you get 2y minus 2x plus 2y plus y minus 20 is equal to 0. So this is 2, 2, 4, 5. 5y minus 2x is equal to 20, which is minus 2x plus 5y is equal to 20. This is my equation 2. So we need to solve these two equations. So I will try to eliminate y. So what we will do is, we will multiply 1 with 5 plus multiply the second with 2 and we will add. Okay, we will add. So we will get equation 3. So 5 into how much? 5 into 5. This is 5 into 5, 25, 25x. Y is anyway getting eliminated. Okay, all right. 5 into 5 and minus 2 into 2. So 4x. So y got eliminated. So 20 into 5. The first equation we have to multiply with 5, sorry. So first equation to multiply 5. So 10 into 5. So 10 into 5 will be 50. 10 into 5 plus this 20 into 2. So this is 50 plus 40, 90. And this is 21x. So x is equal to 90 by 21, which is 3 7s are 3 30s are, which is approximately 3 volts. So we got the x value. So this is 5 into 4.3 minus 2y is equal to 10. So this is 15, 20, 21.5 minus 2y is equal to 10. So 2y is equal to 11.5. That implies y is equal to 5 approximately 7 volts. So we have got this value. This value has how much? 4.3, and this value has 5.7. So I can find any current in the branches. Suppose I want a current in this branch, it will be 20 minus 5.7, that is the potential difference, divided by the 4. So it is 14.3 divided by 4, which is approximately 6 amps. So this method sometimes gives us a faster answer. Now let us move on to the third question. So a figure is shown like this and you have to find the different currents. So here also we will try to find out the potentials at different points. The meaning of this symbol is this wire, wire A, and this wire B. Wire A is jumping over wire B. So from here to here there is only one wire. There is no crisscrossing. The wire is just passing over. Okay. So just write down the potentials. This is 0. This is 24. Because there is no resistor from here to here, it is 24. And all this is a single wire. So this is 24. And this is also 24. And about this point is 0. There is no resistor here. 0. Then again 0. Then again 0. So we got all the points. Whichever current we wish to find, we can quickly find out that. Suppose I wish to find I2. I2 will be equal to potential difference 24 minus 0 divided by 12, which is 2 amps. Okay. Suppose you wish to find I1. I1 is between 24 to 24 potential. Delta V is equal to 0. I is equal to 0. I1 is equal to 0. Similarly I3. I3 also this point and this point same potential. So I3 is equal to 0. If I wish to find current between these 2 points, it is 24, it is 0. So 24 minus 0 divided by 6, which is 4 amps. What will be the direction? Higher potential to lower potential. The direction will be like this. Let's move on to the next one. Let's see this problem. You see here, this is a unbalanced Wheatstone bridge. Sometimes these type of questions are asked. unbalanced Wheatstone bridge. Now why it is like that? Because 6 into 10 is 60 is not equal to 3 into 8. Is not equal to 3 into 8. So the question is find effective resistance. Find effective resistance between point A and point B. So by normal Kirchoff rules also you can apply and you can try the problem, but that will be a little lengthy. So our idea is to convert this into a more simplified circuit. So we'll try to draw a new circuit which will look like this. Basically I am converting this into this format. This is called converting Y to delta format. Y joint to delta joint. Converting into this format, this circuit can be analyzed more easily rather than this. So there is a small procedure there. So we have to find out all this. So this is already known. This is 3, this is 10. So in order to convert this into this, I'll tell you a small trick. You do this calculation first. 6 into 8, 48. Then 6 into 4, 24. 4 into 8, 32. Okay, add them. 8 plus 4, 12. 14, 1. 5 plus 2, 7. This is 10. Alright. Now suppose if you want this particular resistance value, you have to divide with the opposite one. The opposite one is this. So this will become 104 by 4, which is 26. Suppose you want this resistor, you have to see the opposite one, which is the 6. So 104 by 6. 2 3s are 252s are. So this is approximately 17.33. And if you wish to find this one, you have to see the opposite, which is 8. So 104 by 8. So this is 4 2s are and 4 26s are. This is 13. So now the circuit has become more simplified. Now you can see that this and this, they are in series. So it is looking like this circuit now. If you find the resultant of this, effective of this, that's your answer. So 13 plus 17.33, it is 30.33. This is 26 and this is 3 plus 10, 13. So your effective value will be 1 by R dash, which is 1 by approximately 30.33 by 1 by 26 plus 1 by 13. So once you solve this, no, you'll get your R dash value directly. Okay. So the calculations are performed here. You can see the value. Finally, you will get R dash is equal to 6.84. So my plan is to bring this type of educational videos which is going to help students in their preparation for the JEE and NEET exams. And if you happen to like my video, you can like it, you can subscribe it, you can tell it to your friends. And I also wish to start a small batch. I have a lot of years of experience in this physics teaching, and I try to teach a lot of numerical techniques, shorter approaches of complex problems, and try to help the student to achieve a better score than what he is getting right now. So if you wish to join with me, you can contact me at my this WhatsApp number, which is I'm going to mention here, and that's all I want to say. And any particular concepts you want to learn, you can post it in the comment box. I'll try to make some videos on that and try to help you out with some related numericals and some other ways of approaching such type of problems. So let's be in touch. Wish you all the best.